This is TMUA 2016 Paper 1. Over the next few days, maybe a week, I'll just be going through this entire paper, doing a few questions each day, just to help you guys do some revision before the TMUA. So we're going to start from the start. I know some people like to start from the end and work backwards, but I think it's best to put ourselves in the actual test and start from question 1. So this question, first off, we know our binomial expansions, don't we? So let's just write out ax plus b cubed. We know this is going to be equal to ax cubed b to 0 plus 3. I'll write in all the exponents, just for the sake of clarity. And this is going to be a cubed x cubed plus 3a squared x squared b plus 3a x b squared plus b cubed. Now the first thing we're going to notice is that inside our bracket here we've got a plus, and in the expression we have negatives. So what we can say is when we compare our coefficients, we'll do a lot of different arrows. We're going to have a cubed x cubed equals 8x cubed. Do that arrow again. 3a squared bx squared equals negative px squared. And then for the other two, we're just going to do the same thing. I brought the p before the x just to, it's nice to have all the constants on one side, isn't it? 18x, that's that one, and then b cubed equals negative 3 root 3. So the ones of these that we can solve straight away, it's going to be b cubed. All we have to do is cube root both sides. What we can see is that if we have b equals negative root 3, then b squared is going to equal 3. B cubed is going to equal negative 3 root 3. So therefore, b is equal to negative root 3. Another way of doing that is just to express what we have here as, first off, we can times both sides by negative 1. We're going to get negative b cubed equals 3 root 3. Negative b cubed equals 3 to the 1 times by 3 to the half. Then when we multiply, we're going to add the bases. So equals 3 to the power of 3 over 2. Get rid of those 3's on top and bottom and the top, and we just get negative b equals 3 to the half. So b equals negative root 3. That's the more sophisticated method. Now with this one, I know people say we don't like to divide by x because x could be 0. So if we want to avoid that, we can just subtract 8x cubed from both sides. Get this, and now we can just set this equal to 0. So x equals 0, or a cubed minus 8 equals 0. A cubed equals 8. A equals 2. So now, all we have to do is sub them into this. We do the same thing that we did for the first one, and we can get 3a squared b plus p x squared equals 0. So p equals negative 3a squared b. A equals 2. B equals negative root 3. So these negatives are going to cancel. I'm going to get p equals 3 times 4 times root 3. P equals 12 root 3. So therefore we're going to be choosing H as our answer. That took quite a while, especially for question 1, but that's just trying to be more sophisticated, isn't it? Trying to get your working all set out. So on to question 2. Now, if x plus 2 is a factor, so first off I'm going to call this a function. And we'll see why in a moment. If x plus 2 is a factor, that implies that x plus 2 is... That implies that f of negative 2 is going to equal to 0. And this will let us find a, and then after that we can use the long division. What we do know is that a has to be a factor of 2. Sorry, a multiple of 2. And we know that because all the coefficients are integers. So first things first, we can sub in negative 2, and we're going to get 3 times by negative 8, add 13 times 4, add 8 times negative 2, add a equals 0. This is non-calculator, so this is just a little bit of number crunching, isn't it? Add 52, subtract 16, add a equals 0. A equals 24 plus 16 minus 52. A equals negative 12. So then what we can do, now we've got the value for a, is we can set this cubic as a product of a linear factor, x plus 2, which we've been told, and a quadratic factor. Now, I am using a again here. That a is not negative 12, that I'm just using that as a kind of dummy variable. And we know straight away that this a is going to be 3. Now, in college they might teach you to do long division. I think an easier way is to just expand this and then consider comparing the coefficients. So we're going to have ax cubed plus bx squared plus cx plus 2ax squared plus 2bx plus 2c. Those are all our terms. We can just collect like terms now. b plus 2a x squared, c plus 2b x plus 2c. And we want this cubic to be equal to the one we've got where a is minus 12. So we want this to be the same as 3x cubed plus 13x squared plus 8x minus 12. Now for this to be the same, all we have to do is solve it. It's a really easy system of equations. So we've got ax cubed equals 3x cubed. We have b plus 2a x squared equals 13x squared. C plus 2b x equals 8x, and 2c equals minus 12. So these first two ones, a equals 3 and c equals negative 6. I'll do that 6 again. And these ones just help us with these middle two. So what we have is when a is 6, we have 6 plus b. Sorry, when a is 3, 2a is 6 equals 13. So b is 7. Now we have c plus... This last one is really just a check. C plus 2b is going to be equal this value of c, negative 6, and 14, which is going to equal 8, and that 8, and that 8. That's right. So that's a good check. So that's we've got the right coefficients. So this leaves us with x plus 2 and then the quadratic that we found. So this is our a value, this is our c value, this is our b value. So 3x squared plus 7x minus 6. And then this quadratic we want to factorize, and we can do that quite easily. All our options that we're given all factorize, so we know that it's going to have roots. Another way we can check that is just using the discriminant. We can factor this in our heads, or we can use the AC method, or really just whatever method you prefer, I suppose. So we know that we're going to have 3x in our first bracket and x in our second bracket. We're going to have 2 and 3. So if we have -2 here and +3 here, and we can expand this to check it again, we're going to get 3x squared plus 9x minus 2x, 7x minus 6. This is our answer. We look for this in the given solutions. We get 3x minus 2, x plus 3, we get E. E as our solution. Now on to question 3. This is our last one for today. A line is drawn normal to the curve y equals 2 over x squared at the point where x equals 1. So normal to the curve implies that, I'm sure you guys would know this, but if we have a curve like this, in black is our tangent and in red is our normal. So where it cuts through it rather than tangent to it. So if we draw 2 over x squared, we're going to have to draw it for the first quadrant. If you know your graphs, you know that it's going to look like that. And the point when x equals 1 is when we're going to have 2. So here we're going to have 1, 2, x, y. Now it wants us to work out the line cuts the x-axis at P and the y-axis at Q. So first off, we can just add that in our sketch. It's going to look something like this. This B is a little bit ambiguous. We don't know whether it's above or below the origin, but even so, it's just a sketch. It doesn't really matter. To work out the gradient, we're going to want to differentiate. We can use it in our heads, or we can set it up properly. Y equals 2x to the minus 2. So dy by dx equals negative 4x to the minus 3. Divided to x equals 1, and we're going to be left with just negative 4. So remember, that's our normal. Sorry, that's our tangent. So that is going to be this red line. That's a very bad tangent. That red line I've just drawn is going to have a gradient negative 4. So y equals negative 4x plus c. Our normal, if you remember perpendicular lines from GCSE, m1 times m2 equals minus 1. Minus 4 times normal. So that means that our gradient of the normal that we want to find is going to be a quarter. So we have y equals x over 4 plus c. I'm using c again. I've already used it before, but it doesn't really matter. Now we know the point on this line because we know it's normal at the point 1, 2. So we can sub in x equals 1 and y equals 2, and we're going to get, I'm going to convert this 2 into 8 over 4. So we've got common denominators. 8 over 4 equals 1 over 4 plus c. So c is going to be 7 over 4. That should be quite simple why it is. That's our y-intercept, obviously. So the y-axis at Q, that's going to be positive. It's going to be around here, 7 over 4. And the x-axis at P, which should be negative. And for the x-axis, we have to solve y equals 0. So we'll do that over here. I'm going to get 0 equals x over 4 plus 7 over 4. So x equals negative 7. So in fact, our diagram up here was quite wrong. It should be a much flatter line that goes more like that. But again, it's just a diagram, it's not too important, and we can add it on here anyways. This is obviously not to scale, but this is what we're left with. And then it's our triangle. 7/4 on the height, -7 on here, but obviously the length of this is just going to be 7. So the sign on this doesn't actually matter, this bit here. So I'm going to just scribble over that. And we want this length here. This is just Pythagoras, so it's square root of 7 squared, because this is a right angle, plus 7/4 squared. This might look a bit annoying, but what we can do is we can factor 7 out of this. So 7 root 1 plus 1/4 squared. So 7 root 17. I'll show my working for that. Root 16/16 plus 1/16. And again, we can pull out this factor of 4 from the bottom. Same way we did with the 7. So we've got 7/4 root 17. This is option C over here. So we're going to have C as our answer. Hope that was useful. Hope you guys enjoyed that. If you need more help, leave it in the comments.